Hello, grade 8 learner. Welcome to another video lesson in mathematics. In this video lesson, we will be discussing how to identify and simplify rational algebraic expressions. These expressions are used for things that we cannot express as a whole number, so we have to know how to use them correctly. So grab your pen, paper, and module as you start watching and learning from this video lesson. It's another great day to learn, so happy learning! This lesson is based on the K-12 curriculum learning competency. The learner illustrates and simplifies rational algebraic expressions. By the end of this lesson, you, the learner, should be able to identify rational algebraic expressions and to simplify given rational algebraic expressions through appropriate factoring techniques. To start with our lesson, we should first ask, what is a rational algebraic expression? A rational algebraic expression, or RAE, is a ratio of two polynomials which we symbolize as P and Q, where Q should not be equal to 0. An RAE looks like this. Does it look familiar? That's right. The rational algebraic expression is a fraction. Take a look at the following examples. Now that we know what a rational algebraic expression is, let's take a look at examples that are not RAE. What makes each of these examples not an RAE? For the first example, it's the radical sign. For the second example, it's the exponent of x, which is a fraction. For the third example, again, it's the exponent of a, which is a decimal. And for the last expression, it's the term in the numerator, which is a fraction. All of these are not supposed to be found in polynomials. Therefore, they should not be seen in RAEs. Now, is this expression not an RAE? Yes, it is not an RAE because of the negative exponent. But unlike the previous examples, this expression can be rewritten as an RAE because it has a negative exponent. How do we do that? So first, rewrite the expression with a negative exponent. Note that a negative exponent means the base should be written as its reciprocal. Once we do that, the negative exponent can now be expressed as a positive exponent. That is what happened to x raised to negative 2. Looking at the expression, we have to rewrite the expression again because we can't have a fraction in a fraction. We do that by dividing negative 2 by 1 over x squared because a fraction can also serve as a division sign. That means we multiply negative 2 by the reciprocal of 1 over x squared, which is x squared. Doing that results to negative 2x squared over 1, or simply negative 2x squared, which is also considered as a rational algebraic expression. This only means that before we say that an expression which has a negative exponent is not RAE, we have to rewrite first the expression, then check that the expression is really not an RAE. Now that we know what a rational algebraic expression is, how do we simplify them? If an RAE is in its simplest form, its numerator and denominator should not have any common factors except 1. Take a look at the following examples. If there are no common factors between the numerator and denominator of an RAE except 1, they are described as relatively prime expressions. Even binomials or polynomials should not have any common factors. And no, x is not a common factor in each of these expressions. To simplify rational algebraic expressions, we follow these steps. First, we rewrite the numerator and denominator as factors. Here, we are going to use what we have learned in our previous lessons on factoring. In this case, since the numerator is a monomial and the denominator is a binomial, common monomial factoring is the appropriate factoring method to use. After factoring out the expression, we divide or cancel out the common factors. In this case, we see that 7x is the common factor between the numerator and denominator, so we cancel that out, leaving x and x minus 5. Be careful though, we only cancel factors, not terms. That is why we don't cancel x even if we see it on both numerator and denominator because it is considered a term, especially in x minus 5. Now that we've canceled the common factor, what remains is the simplest form of the expression, which is x over x minus 5. Let's take a look at another example. This time, we have an RAE whose numerator and denominator consist of trinomials. To simplify this expression, we follow the steps that we have just discussed. First, we factor out completely the numerator and denominator. In this case, we apply the process in factoring quadratic trinomials since our numerator and denominator are trinomials. Factoring correctly results in this expression. After we factor out the expression, we cancel out the common factors. We see here that p plus 2 is a common factor between the numerator and denominator, so we cancel them out, leaving p minus 11 and p plus 3. Again, we only cancel factors, not terms, so we don't cancel out p. If we did the process correctly, we will have the simplest form of the expression, which is p minus 11 over p plus 3. Did you follow the discussion? Good job if you did. If there are still some things that are not clear to you, you can rewind this video, read your module, or ask help from your teacher to improve your learning. To check how much you've learned, try doing this exercise. Simplify the following rational algebraic expression. Pause this video and solve first before we move to the answer. Done? If your answer is x minus 1 over x plus 2, then you got the correct answer. If you didn't, check the solution to see where you went wrong. Congratulations for finishing this video lesson. We hope that we have made this topic clearer for you. We leave you then with a final quote from Steve Jobs: Learn continually. There's always one more thing to learn. Keep learning, dear learner, and we'll see you again in our next video module.